welcome to December 14th LeetCode Challenge. Destination City. You're given an array of paths where path at index I is the list of city A at index I and city B at index I. This means that there exists a direct path going from city A to city B. Return the destination city, that is, the city without any paths outgoing to another city. It's guaranteed that the graph of a path forms a line without any loops. Therefore, there will be exactly one destination city. Say, for example, we're given the following path in example 1. We're given an array, a list, and each list contains a city A and city B. If we were to basically traverse, draw this out, kind of visualize it, I guess. Starting at London, we move to New York. New York, we move to Lima. To Lima, we move to St. Paulo. And that's basically the trip consisting of all these paths and cities. That's intuitively what it's looking at. Similarly, if we were not given actual city names, but we were given letters. So all the possible trips of the following list of strings are BC, DB, and CA. And we know that if we travel starting at destination D, we go to B, we go to C, we go to A, based on these pairings here. Then from B, we go to C, go to A, and then we can also truncate that as well. So we move C to A, and then the final destination is clearly A. So if we were to do all possible arrangements of the trips, then it would all lead to destination A, right, no matter where we start. And that's going to give us a good hint of how to approach this question, actually, because see here, it gives you all possible trips, and it narrows it down. If we're given a path that contains only destination A and destination B only, then we know that we return destination B, because that's the only path to go from A to B that exists. That is not circular, and it is a linear path. Our constraints are that the path length is between 1 to 100, and each index length is equal to 2. So that means that each list is consisting of 2 elements. The name of city A and the name of city B has between 1 to 10 characters. By definition here, it says city A cannot be equal to city B. All strings consist of lowercase or uppercase English letters and the space in between characters. So, for instance, we're given from just maybe one string or just a random city. Alright, how do we go approaching this question? It seems to be easy, but it is quite a brain teaser here. So if we have basically a list of a list, and we want to keep track of going from one area to another, I guess the best approach would be using a hash set, where we would create a hash set that has an outgoing hash set, and that represents all the cities that we have been outgoing path. Then we basically have to iterate through all the outgoing paths here, and if the outgoing path does not equal to the incoming path, then that means that it's a connection, right, between A going to a B going to A of another index. So basically need to find a outgoing path that is unique, and that is destination city. So let's try doing that again in better words. We will first create a hash set, and then that has outgoing, that represents all the cities that have outgoing paths. We iterate through all the paths. For each index I, we add a path to the I-0th element that has outgoing. So then we just basically iterate through all the paths again to select the candidates for the next element. And that's how do we go about doing that. Let's first initialize a set of strings. this is going to be our has outgoing. This is where we're going to check if it has outgoing place or not, and it's going to be hash set. First thing we should do is iterate through the size of paths to add to our has outgoing set. So for integer I equal to 0, such that I is less than the path dot size, incrementing by 1. Iterate through each element in paths to define whether it has outgoing or not, and then what we want to do is take our has outgoing hash set, and we're going to add our paths at get index I, and get the first element, or the basically the city A from each index I, and we're going to add it to our has outgoing hash set. Alright, we have that, and then we could do another parallel for loop to look for the second element as well. And we're going to first, for int I is on the same level, equal to 0, such that I is less than path.size, semicolon, plus plus. We're going to develop a string, initialize a string called candidate for the return, basically the final destination. And we are going to, or just call it destination. No, that's too long. Okay, whatever. It's already done. And that's going to be paths dot get index I, and then we're going to get the second element in the array, or the list. Alright, and this is going to be city B. This is all the city B possibilities. If we find that the city B exists within the has outgoing city A, that means it's not a candidate. So we're looking for a unique city B that does not exist in the first element of any of the list. So to do that, we do if not has outgoing dot contains the destination, then we know that the destination, the second element, city B destination, is unique. Well, it's the one that doesn't have any incoming city A's, so therefore we can return the destination, because it is the city destination that we're looking for. If all else fails, return empty string, because we have no candidate. So let's run this. Let's run this. Alright, seems like it's a good idea. I mean, looks good so far. Awesome. So time complexity wise, we have big O of n, because we do 2n basically loops here for for loops, but they're side by side. So if we first iterate through the path to populate the has outgoing hash set, which costs big O of n. Next, we also iterate through the path again to find the answer, for whether we check to see if the destination is contained in the has outgoing set or not. So either way, it's the iteration itself for happening parallel, and parallel costs big O of n time complexity. Space complexity is also big O of n because we store it in a hash set which is of worst case size n. Oh, actually no, it is size n because we put in one element for each element in our paths. So it's big O of n as well. And that is it. Have a great day, everyone.